by saying that a ship moving ahead will have an apparent pivot point approximately a third of the ship's length from the bow, with the opposite true when running astern. Explaining motion using pivot point theory means that we can picture it in terms of levers instead, making it much easier to understand. We can say that the rudder is effective when running ahead because it's acting on a larger lever around the pivot point. We can also say that the tug generates rotation when pushing in the centre because there is a lever between the tug and the pivot point, which disappears when the tug is pushing at the pivot point itself. We can even say that when working with two tugs, the after tug is going to be more effective because it has a larger turning lever. It really doesn't matter that the difference in effectiveness is actually caused by induced rotation from the movement of water that affects the stern more than the bow while the vessel is moving ahead. It's a similar story with the bow thruster, of course. With a stationary vessel, the movement will tend to be about the pivot point at the end opposite from which the force is applied. Pivot point theory states that when moving ahead, the thruster will be less effective because it has a smaller lever, and when moving astern it will be more effective because it has a larger lever. This all appears to be true, but it's actually explained due to the motion of the vessel.